Welcome to today's session, providing disaster recovery to business-critical Oracle workloads on VMware Hybrid Cloud. My name is Sudhir Balasubramanian. I'm a staff solution architect and the Oracle practice lead for VMware. I'm joined by Dean Bolton.
Welcome, everybody. Thank you for joining us today. My name is Dean Bolton, Chief Architect and Co-founder at License Fortress.
Thank you, Dean. So let's take a look at the agenda for today's discussion.
Essentially, we'll start with talking about benefits of running Oracle workloads on a VMware vSphere platform. We'll then delve into what customers really want, which is VMware Hybrid Cloud. We'll touch upon one of the cloud options that we have today, which is VMware Cloud on AWS. I'll speak a bit about deploying and migrating Oracle workloads on VMware Cloud on AWS, and then I'll pass the ball over to Dean, and he would delve on the Oracle licensing aspect, the License Fortress, and then we will wrap up collaterals and questions and answers. All right. So let's take a look at some of the benefits of running Oracle workloads on a VMware platform. And even before we start taking a look at the advantages of virtualization, right? Let's understand what Oracle business critical applications requirements really are, and then what are the benefits of running these BCA or these business critical application workloads on a VMware vSphere platform. See, any application that's deemed BCA or business critical will have certain SLAs. They'll have certain RTOs, they'll have certain RPOs. Essentially, they'll have a set of stringent requirements. See, for example, availability. Well, that application must be highly available. It must be resilient. It must be redundant, etc. It should also be very performant, which means process should complete in a timely fashion. It should avoid bottleneck. And then recoverability, which means your RTO, your RPO, your mean time MTD, your WRT, so on and so forth, they must all be very low, and any and all of your recover plans that must be verifiable and repeatable, right? You should be able to scale up, you should be able to scale out, you should be able to inculcate all of the security aspects in your application, in your business critical application. Right. So these are some of the benefit, right? Not particular to BCA, which actually helps all workloads, right? For example, resource maximization. So for example, with the server resources increasing too much for one application instance, what happens is virtualization, it improves resource utilization. It reduces wastage, which means now you can fully utilize the hardware, and yet you can maintain your application isolation. We spoke about performance. So IO is not an issue because you're able to scale up, you're able to scale out, you're able to add newer hardware to a vSphere cluster, or even if you have features like RDMA or let's say persistent memory, that can increase your performance. The fact that you have enhanced availability, right? For example, native application HA features, right, are incomplete for most of the critical apps, but vSphere HA that complements the native app HA features or any of the application HA, what happens then is you have improved availability. Let me give an example here. Try running Oracle RAC on vSphere HA. So what Oracle RAC gives you is application level HA right out of the gate, and what VMware vSphere HA gives you is infrastructure level HA. And now if we were to stretch that across metro distance, what we get is a site level high availability. So you get 3 different levels of high availability simply by stretching or simply by putting your Oracle RAC on a VMware environment and then stretching that VMware environment across metro distance, hereby coming up with the enhanced or let's say an extended Oracle RAC cluster. And then you have the rapid provisioning and scaling, the job security, which is basically, you can't get to the cloud without virtualizing it first, and the fact that you get lower TCO, which is significant savings in power, cooling, data center space, so on and so forth. All right. So with this slide, as we can see, the processes are actually getting very faster, right? They're getting faster, caches are getting bigger here. The NUMA awareness is better, hypervisors are smarter, storage is faster, and all of this makes it very perfect to virtualize any application. So with any version, with most of the vSphere version, right, VMware, it has been increasing the performance and scalability by leaps and bounds. So any lingering performance concerns relating to VMware virtual machines, that is clearly due to a lagging perception from a very early generation, which basically had some limited capabilities. So moving on to vSphere 7, right? So with the latest release of vSphere 7.0, there has been a lot of features added. I mean, we don't have the time to go through all of them, but I do want to call some of them out, right? Some of the notable ones out for business critical application, namely improved distributed resource scheduler or DRS, the assignable hardware, refactored vMotion. Moving on to the design methodology, right? See, let's take a moment and look at the design methodology here, right? The flow chart here. I mean, essentially, if you look at the Oracle design workload methodology, everything starts with requirement gathering, right? And then we have to sell the project to some stakeholders for buy-in. And then that is followed by, you have to understand the current environment constraints. You then understand the database workload. You measure it using your AWR, using your SAR, performance, so on and so forth. And then you look at different various migration strategies. And that could also include the big endian to the little endian as well, right? And then that is followed by design considerations for high availability, for DR. You then inculcate the backup and recovery, and you make sure that your system is completely monitored, right? You put monitoring in, you put performance tuning in, and last but not the least, you also have to take Oracle licensing into account, right? But if you look at all these steps of the design workflow, well, there is no one step that screams out at you and say, you know what, that is particular to a architecture, whether it's a physical or a virtual. So all we're trying to say here is there is no change in the design methodology when one virtualizes an Oracle workload on VMware versus running Oracle workloads on a bare metal server. Right. So this slide talks about some of the best practices, and again, there's an Oracle DBA best practices guide. The link is there at the bottom of the slide here. But the key thing to keep in mind is best practices, it needs to be inculcated into every layer of the stack, including the virtualization layer, to ensure that the workload can take advantages of the underlying stack. So essentially what we say is when you have a virtual machine, make sure that you use all four SCSI controllers, and if possible, and of course it is with RHEL 6 and OEL 6, make sure that all these SCSI controllers are para-virtualized, and para-virtualized means running on rocket fuel. Same thing, when you have your network adapters, especially for Oracle RAC Private Interconnect, make sure that they are VMX Net 3, right? Make sure that you design with NUMA in mind, right? Always design for performance in addition to capacity for storage, which means more disk is faster, right? But again, we won't have time to go through all of the performance best practices, but the link is there in the bottom of the slide here. So moving on. And let's see what customers actually want. What do they really want? What they really want is a VMware hybrid cloud. And let's look at this. So for customers, see, as customers, when they move to the cloud, they're essentially looking for ways to get the best of both the worlds, right? Essentially, they want to have the on-premises advantages along with the cloud advantages. But what they want is they don't want to buy new hardware. They don't want to have the refactoring factor in there. They don't want to re-platform. They want to leverage their existing investment, their skill sets, and their tools. So with on-premises, they are able to use their familiar tools and processes that you're very familiar with. They are able to leverage existing investments. They are able to maintain the unique hardware configurations and yet have a granular control over placement of apps and data. Now, with public cloud, they want to scale faster. They want to reduce the cost. They want to establish global footprint. They want to have that pay-as-you-go model. And they also want to access broader range of services. So this is some of the current hybrid offerings that we have today. As of now, we know the VMware Cloud on AWS, that was GA as of 2017. We also have these cloud offerings in the horizon. So you have the OCVS, or the Oracle Cloud VMware Solution. We also have the Azure VMware Solution. And last but not the least, we also have the Google Cloud VMware Engine. And the GA is tentative sometime this year. But again, please do have a link at the bottom of the slide. Have a look at that. That'll give you more ideas to what the cloud offering really entails. But then let's focus on VMware Cloud on AWS, and let's see how we are able to migrate and deploy Oracle workloads on VMware Cloud on AWS. All right. So VMware Cloud on AWS, this is a jointly engineered cloud solution, cloud service or a solution between VMware and AWS, Amazon, right? So VMware Cloud on AWS that integrates the VMware flagship, the compute, the storage, the network virtualization products, essentially your vSphere, the vSAN, and the NSX, along with the VMware vCenter management and robust disaster protection. And it essentially optimizes them to run on dedicated, which is very critical here. It's dedicated, it's elastic, Amazon EC2 bare metal infrastructure that's fully integrated as part of the AWS cloud. So now VMware Cloud on AWS together with VMware Hybrid Cloud Extension, we call that HCX, that enables customers to accelerate their cloud migration in the simplest, fastest, and the lowest risk way with compelling TCO. VMware Cloud on AWS that brings the VMware's enterprise class software-defined data center, SDDC, software to the AWS cloud and enables customers to run production applications across VMware vSphere-based private, public, and hybrid cloud environments with optimized access to AWS services. So this solution or this service is delivered, sold, and supported by VMware and its partners as an on-demand service. And so VMware Cloud on AWS is essentially it enables IT teams to manage their cloud-based resources with familiar VMware tools. I mean, without the hassles of learning new skills or utilizing any new tools. So this is an example setup here, right, between on-premises and VMware Cloud on AWS, right? So essentially, this is a 3-site lab setup, right, which includes the on-premises site A and site B, and it has a connectivity to the VMware Cloud on AWS. So the on-premises vSphere cluster on site A, that's running production workloads. And site B on the right, that's running the non-production and the disaster recovery workloads. Now both site A and site B, they are in a hybrid link mode. Site A and site B, they are dedicated clusters or they are separate clusters. They have access to their own dedicated storage, so nothing is getting shared between these two clusters here. Site A is connected via layer 2 VPN to VMware Cloud on AWS, as we can see, and site B is connected via HCX, which stands for Hybrid Cloud Extension, to VMware Cloud on AWS. And essentially both the sites are 4-node vSphere 6.7 clusters. They are Dell PowerEdge servers, 2-socket 14 cores each. I'm not going to go too much detail into the spec of the servers here, right? But if you look at this current solution, it designed and deployed 3 separate environments, right? So as I mentioned before, site A was production. So essentially a 2-node Oracle rack, it's PRD rack here with 2 rack instances, 1 and 2. And then site A also had what's called the FARSync, the production Oracle FARSync. And then site B had the 2-node Oracle rack to Oracle rack, the DR, right? And then the VMware Cloud on AWS that essentially is in a stretched or it's in a stretched cluster deployment here, right? And it has 6 servers. So basically it's in a 6-node stretched cluster, and then it's stretched across 2 AZs, so AZ1 and AZ2. So if you look at it, it has 3 servers on AZ1, 3 servers on AZ2, right? And then the VMware Cloud on AWS that uses vSAN. And then what happens is there's a new capability that is introduced with the vSAN here, right? And essentially what happens is you have 2 logical data stores, one for management VM and one for the customer VM, right? And then you have the vSAN fault domains that is configured to inform the vSphere and the vCenter which is host is residing in which availability zone, right? And here every fault domain is named after the AZ or the availability zone it is residing in, right? And then the thing to keep in mind here is Oracle Rack on premises, right? If you look at Oracle Rack on premises, that requires the shared VMDKs to be deployed with the multi-writer attribute, right? And that needs to be eager 0 thick, right? Before 6.7, which is vSAN 6.7 P01. But starting vSAN 6.7 P01 or VMC SDDC version 1.8 version 2, your shared VMDKs in the multi-writer mode, they do not need the VMDKs to be provisioned as eager 0 thick. The KB article is 212.1181, and that entails a lot of storage saving for the customers here, right? The thing to keep in mind here is current restriction of the multi-writer mode is to disallow storage vMotion. So this is the current setup that we'll be talking about today during the deployment and the migration examples. All right, moving on to the next slide. All right, so deploying non-Oracle rack workloads on VMware Cloud and AWS, right? If you look at it, essentially deploying non-Oracle rack workload in VMware Cloud and AWS is exactly the same as one would do on premises. So with VMware Cloud and AWS, like I said before, your ESXi host, they traditionally reside in an AWS AZ availability zone. They are protected by vSphere HA. In this use case, what we did was we deployed a virtual machine from a template, right? And that was OEL 7.4, Oracle 12.2 grid infrastructure, right, RDBMS binaries, and then that used the Oracle ASM with the Oracle ASM filter drivers. And we made sure that all of the best practices for running Oracle workloads on VMware SDDC that was followed in accordance with the DBA best practices guide. So the deployment is exactly the same as one would do on premises. Now, changing tack and talking about deploying Oracle Rack workloads on VMware Cloud and AWS, it's essentially the same as well. So there is no difference. There is no difference deploying Oracle RAC on VMware Cloud and AWS than as one would deploy Oracle RAC on premises. There's only a subtle difference here, and that difference is creating a logical network for the Oracle RAC private interconnect in AWS, as opposed to creating, as normally one would do, a dedicated distributed port group on premises. But apart from that, each and every step, the grid infrastructure, the Oracle RAC install, and coming up with the private, the VIP, the scan, everything is exactly the same. Again, please follow the Oracle databases on VMware best practices guide when one would set up a Oracle RAC, or for the sake of discussion, any Oracle workload on a VMware environment. And the link at the bottom that goes into more detail about deploying Oracle RAC workloads on VMware Cloud on AWS. All right. So we spoke about VMware Cloud on AWS, and there's another flavor of VMware Cloud on AWS, which is what is called the stretch cluster for VMware Cloud on AWS. So essentially what happens is when we have this VMware Cloud on AWS, which means you, with the traditional model, all your ESXi servers are in an availability zone, AZ1, right? But you are able to stretch that cluster across metro distances, in which case you're able to provide the site level high availability. So in this example, we had 3 servers in AZ1 and 3 servers in AZ2, and you were able to stretch your Oracle RAC across metro distance, and that gives you what's called the extended Oracle RAC, which essentially provides you greater availability than a traditional Oracle RAC. The reason being, you're able to now stretch that across multiple sites. So the key thing to keep in mind, right, whether it's running Oracle RAC on premises in a traditional SDDC cluster, or if you're running it in a stretch form or in a stretch fashion, we have to ensure that the Oracle RAC virtual machines are not scheduled on the same physical ESXi server, because that negates the entire HA proposition, right, that the VMware SDDC has to offer. Essentially, the infra level HA provided by SDDC to complement the app level HA that Oracle RAC provides. So to achieve it, what we need to do is we need to specify virtual machine anti-affinity rules for Oracle RAC VMs that essentially forces these RAC virtual machines to remain apart during the failover actions. So now, with this extended Oracle RAC, right, which is basically on the stretch clusters for VMware Cloud and AWS, what we need to do is make sure that the Oracle RAC virtual machines are stretched across site, which means they don't all at one land on the same site at the same amount of time, let's say at the same time. So this is basically achieved using what's called compute policies, tags, and attribute that allows you to attach metadata to object in the vSphere inventory. So deploying and migrating Oracle workloads from on-premises to VMware Cloud and AWS, has been documented in detail. So there's a reference architecture document that's provided in the resource page. I've also given a link here at the bottom of the slide, and there is a YouTube video that basically goes into the deployment details as well. So you guys will have these slides at the end of the event, plus you'll have a lot of collaterals to go through. All right, so we spoke about the deployment aspect of it, right? How we are able to deploy a non-Oracle RAC, how you're able to deploy an Oracle RAC, right, on VMware Cloud and AWS. So let's now change tracks and talk about how we're able to migrate a non-Oracle RAC or a single instance Oracle workload to VMware Cloud and AWS. So essentially in this section, if you see, you have a single instance Oracle virtual machine which is set up on premises, and that is successfully migrated to VMware Cloud and AWS transparently in a couple of mouse clicks. So same as before, the virtual machine was running OEL 7.4. It was an Oracle 12.2 grid infrastructure, RDBMS binaries, Oracle ASM disks were created using the 12.2 filter driver, ASM FD, and this was a multi-tenant option running a pluggable database PDB1. So by following these above mentioned steps here in the slide, wherein we choose the migration method, the resource pool, the storage, the destination network port group, one can seamlessly and transparently migrate the single instance workload to VMware Cloud on AWS. So the blog at the bottom of the screen here, the link to the blog, that basically goes, it shows every screenshot. It shows step by step as to how this was done. There's a demo as well on YouTube, which we uploaded. So let's now move and see how we are able to migrate an Oracle RAC on VMware Cloud on AWS. So let me expand this slide up here, right? So the most important thing to reiterate is starting SDDC version 1.8, 1.8 version 2, the shared VMDKs in the multi-writer mode, right? They will no longer need the VMDKs to be provisioned as Eagle 0 tick. So one could use thin provision VMDKs as such. So even before we talk about that, thing to keep in mind here is this, right? Now, Oracle RAC virtual machines, they have 2 types of VMDKs. See, One is the non-shared, the non-database VMDKs, which essentially are your operating system disks that house the root file system, and the Oracle binary VMDKs that houses the Oracle grid infrastructure and the RDBMS, the /CO1. And then the second genre of disk is essentially the shared eager zero thick database VMDKs that uses the multi-writer attribute. And as mentioned before, there are certain limitations using the multi-writer attribute, and that can be found at the KB article 212.1181. The most important limitation being, or the restriction being, the vSphere storage vMotion migration currently is not supported for shared devices or shared VMDKs using the multi-writer attribute. The VMware the engineering is working on it. It's there on the roadmap, but as of now, I don't have a date to give you guys, but the limitation currently is storage vMotion migration is not supported. The migration steps are shown in the slide here, so I'm not going to go into through each and every step, but as you can see, it's very easy. You just have to power it off, remove it, and then do a storage vMotion, put it back. This did not used to be the case when we used to have eager zero thick disk, because there used to be a bit of a problem there. With thin provision disk, it's easy. It's very easy, seamless, and transparent. Right. So essentially, at the end of the exercise, right, if one were to look at the original, the on-premises and the VMware Cloud on AWS setup, this is exactly what it looks like. You still have your two-node Oracle rack, right, which is on site A. That's your primary two-node Oracle rack, and that is connected to the synchronous data card replication. That you have a synchronous data card replication from the production Oracle rack to the far sync. You have VMware Cloud on AWS. Again, that's connected to L2 VPN from site A, and also HCX to site B. And that has your standby two-node Oracle rack, and you have an asynchronous data replication that's happening from the Oracle far sync on site A to the standby Oracle rack on VMware Cloud on AWS. And then what we have actually done is we have now offloaded the RMAN backup that we used to run from the production site over to the standby side, so that you don't take away cycles from the production Oracle rack on the production site, and that could be used for user processing, right? You're able to offload, the backups to your standby site. All right, let's talk about migrating Oracle workloads from on-premises to VMware Hybrid Cloud, just like a summary. So essentially, the migration must take into account the best practices guide for the VMware, or the best practices for the VMware vSphere specific version. One also has to look at the Oracle on VMware best practices guide. See, once we have landed the Oracle workloads on the VMware vSphere environment, right, the next steps are saying if cloud is an option, and if that is the case, right, one would go down the route. Now, this session, we understand is focused on the VMware Cloud on AWS use case, but then the customer use cases for choosing any hybrid cloud, right, approach, right, that is exactly the same. So that is no different.
Thank you very much, Sudhir. And now to talk about that other topic, not the technical part of it, but the licensing part. And it's last but not least because of the dollar figures involved around some of the Oracle software products. So a lot of times these licensing conversations can drive a lot of the decisions about where and how you run your Oracle workloads. One thing that I like to always start out with is the terminology in the Oracle contract itself. Now, I've been helping customers with Oracle audits for over a decade now, reviewed hundreds of contracts going back into the early 90s. And since Oracle came out with the processor definition in the late 90s, every single one of these contracts has had the same language in it. And that's the part highlighted here, that a processor shall be defined as all processors where the Oracle programs are installed or running. Now, this is the basis for all of your core technology licensing, which is database and middleware. It doesn't matter if you're doing it on the processor basis or the named user basis, they all refer to this. The interesting part about this is nowhere in this language or the rest of the contract do you see anything about how you control where those Oracle programs are installed and or running. That is completely up to you. But the key point of that is to note the contractual language in there, and we'll talk a little bit more of the implications of that. One thing that we see a lot, especially around running Oracle on VMware, is that Oracle uses fear, uncertainty, and doubt, or FUD, around licensing. And there are very unclear rules out there about how you're supposed to license Oracle in a number of different scenarios. But some of the common false claims that we see is that virtualized Oracle is expensive. It's not true. there is a price tag for Oracle. They spent a lot of time in research and development on the product. I've been working with Oracle Technologies for over 20 years. I think it's one of the best databases out there, very fine ERP, a lot of good products in there. So really choose the right product and license given your business requirements and budget. Second thing we see a lot is that non-Oracle virtualization, talking about VMware, requires more licensing. Again, license the environment that you require, use the tools available to restrict the Oracle workloads, and disregard the partitioning policy. And we'll talk more about that policy in a little bit. And finally, one that we see quite often is that OVM is better for licensing. That's just not true. Unless you're talking about some edge cases around engineered systems like the private cloud appliance, Exadata, the database appliance, OVM licensing is exactly the same as VMware licensing on commodity hardware. So with that FUD out of the way, we really try to emphasize that there are two routes for you doing your Oracle licensing. One, which is what we term the Oracle LMS method. This is really where the customer sometimes takes their architecture and asks Oracle how to do the licensing for that architecture. And as strange as it sounds, that's something we don't recommend. Do not go to the owner of the IP to ask them how to license the IP that they own. Now, there are some upsides to this. You can get verified by Oracle for being in compliance. You can get a VMware exception around it, and often your LMS audits are less contentious. Now, the downside of that is that, one, you might have been in compliance when you first did that, but there's no guarantee that you stay in compliance on day two. But really, the biggest downside is a lot of times that's cost prohibitive or operationally prohibitive, especially in VMware. They're usually asking you to create dedicated vCenters, network isolation, storage isolation by both product and license type. And that can add a lot of cost, both capital and operational in there, and a lot of just overhead in terms of managing and maintaining all of those different environments. And really what we like to say is, in the other view of the world, the contractual view, that's not required. It's really where you set up your workloads and control them per your contractual rights. You are really telling Oracle just what you need in terms of licensing, and then going about your business in there and dealing with the audit ahead of time, but being prepared for when it comes down the road. Now, the nice side of this is that you don't have to do all of this dedicated or isolated environments aside from what your business actually requires. So it gives you a lot more operational flexibility, and it really allows you to maximize your Oracle license utilization. Those are the two things we talk about a lot at License Fortress, is both compliance and optimization. You never want to have a compliance issue, and you also want to make sure you get the most value out of those Oracle software licenses. Now, the downside is with the contractual method, your audits can be more contentious, and a lot of times, depending on what you do, they will be more contentious. Now, we'll talk about that more and how License Fortress can help. With those two views of the world, though, if you go down that second route and look at the contractual obligations, you have a lot more flexibility than what you might have thought before. One thing that we like to say is my co-founder, Mike Corey, has come up with this term called Galaxy licensing, the very top row in there. And that's basically, if it exists in the Galaxy, you have to license it for Oracle. Basically, look at your environment, count up all of the vSphere cores, and it doesn't matter if they're in different clusters, different data centers, whatever it is with the newest versions of vSphere, so 6.0, 6.5, 6.7, 7.0, and Oracle wants you to license them for their workloads. Now, from a management and functionality perspective, that's great. Your Oracle workloads are licensed to run everywhere. But your CFO and finance department might not be too happy about the price tag that comes along with it. And finally, in that risk column, we're talking about risk or difficulty during an LMS audit. It's very low because you've really licensed everywhere for those Oracle workloads. However, despite what you might have heard, you still have a lot more options when running Oracle on VMware. So you could set up a dedicated cluster, even in the newest versions of vSphere. Your management's pretty easy. You set up 3 nodes, you can do HA, you get a lot of the functionality in there, and you've obviously driven your costs down significantly from Galaxy licensing. At this VMware cluster level, you're still in a low risk category in there. The LMS auditor will probably give you a little bit of a hard time in there, but not too much. It's still an accepted method of managing your workloads. Now, the next 2 lines in here is where the risk goes up because you're driving your costs down quite a bit. So next up would be sub-cluster licensing. And we see this a lot for customers who are doing newer environments where they're running HCI in there. Some hybrid cloud applicability in here as well, but you got to be careful around the maintenance in there and the specifics. But really what we're talking about is, say you have a 4-node cluster, your Oracle utilization requirements only need 2 of those nodes. So you can just pick out those 2 nodes, use technologies to restrict those workloads to those nodes, like host affinity and anti-affinity rules, and go about your business. So you've effectively halved your costs for Oracle because you're only licensing 2 of those nodes. Your management and functionality is still pretty good. You have to be a little bit more careful around HA events and your maintenance, but you've saved a lot of money. Your risk does go up. So you do need to be a little bit more careful in that scenario compared to the other ones in the event of an Oracle audit. And finally, you still have the ability to go further than that, so you can pick out ESXi processors or sockets and restrict your workloads there. So you're driving down your cost even further, but now your management and functionality are really getting impacted. vMotion doesn't work. You have to be very careful around HA. And while your cost has gone down significantly, you do have a lot more work ahead of you in the event of an Oracle audit. Now, specifically for hybrid clouds, and this is what we're talking about in this session today, is some of the implications there for how you do licensing. So one thing that Oracle likes to put out there is the data recovery policy. And that's how you do licensing in a lot of DR environments, which is a very common scenario that we see for hybrid clouds. Now, if you look at that policy, which actually was just updated a few months ago, Oracle wants you to license the entire environment on the same basis as your production environment. Now, that can obviously be very expensive. You're licensing that entire environment for production workloads when it may not be running in production workloads at all. And the whole point of clouds nowadays is to be able to expand and shrink as needed. So if you're licensing the full hardware there, you might be paying a lot more than what you really need, and it's not contractually required. Contractually, Oracle licenses are virtual. And if you have stretched storage between those environments, you may be able to use the Failover Clause, also known as the 10-day rule, to license that environment for your DR testing or even a short-term DR event without having to pay anything extra. Now, that might not apply to your specific scenario, so you still have a number of different ways of doing that license. You can license that environment for non-production. You can license it for disaster recovery testing only, which usually is a fraction of the time you'd be running your production workloads in there. And you can also start looking at some consolidation options. So it might be your disaster recovery footprint, but also your dev test environment. A lot of scenarios in there that can help you increase that utilization of those Oracle software licenses without having compliance issues in there. So as I mentioned in the last slide, the Failover Clause is a great one. And if it applies, this allows you to utilize environments without having to actually buy licenses for it. Now, there's a lot of different variations on it nowadays, and you have to be careful of what your contract says versus what Oracle's data recovery policy says. As I just mentioned, they updated that a few months ago to actually give you a little bit more privilege in there. Instead of it being 10 days, now it's 10 24-hour periods. So if you have a maintenance window that starts at 11 p.m. at night and runs until 2 a.m. the next day, with the new policy, that's actually 1 24-hour period instead of previously that would have been 2 days out of your 10-day rule. However, with every carrot, there seems to be a stick. So while they've changed that, they've also incorporated the VMware partitioning policy in there as well. So you need to be very careful around how you leverage that. And it almost comes down to a customer by customer basis for what your contract says, what you're doing for how you can best utilize that. Now, if that doesn't apply to you, you can always look at, again, other options for do that licensing. So if you're running your DR testing for a set period of time or specific times over the year, maybe it's more efficient to do your DR licensing by named user plus. And with VMware, you can really control the workloads where those DR tests are being done. So you might want to go ahead and run all of your DR tests on just one ESXi host and stagger it based on time or utilization in there to validate that your DR testing works as expected. But then you only need to license one host in there, and you could do that by named user instead of processor licensing if that's applicable to your specific environment. The other alternative there is again, combining environments, right? You have this powerful hardware that's just sitting there for a disaster, which hopefully never occurs. So how do we make the best use out of that hardware? Can we run our non-production workloads in there? Can the environments be turned off or turned down in the event of a normal operation where there's not a disaster happening? A lot of options in there, again, all about how to increase the utilization of those different environments. Because everything has a cost, and everybody nowadays seems like they're trying to do more with less, especially in IT. Now, that was a lot of information. What I really hope that conveyed is that the license management part of it is complex, and there are implications for how you handle that technically that can have an impact on how your audits go. And so at License Fortress, we tried to simplify that for customers with our software tool called License Fortress Discovery, but it's providing Oracle license management as well as audit protection, which is unique in the industry. What we've done is tried to modernize that Oracle software asset management. We've taken our technical expertise, wrapped it up with our licensing expertise around audits, and we've also partnered with some of the top law firms around there, including Art Beeman and Joel Muchmore, who are the lawyers from the Mars v. Oracle case, if you've heard of that one before. And we've also wrapped it with a full financial guarantee. So it allows us to provide a full peace of mind to customers through the most comprehensive Oracle software asset management solution currently available. Just quickly about how we deliver that. It is subscription-based, but some of the things that you get there, because we try to keep it very simple in there, is that we really have two offerings in there around License Fortress Standard and Premier. In both those scenarios, we're helping you set up the tool so that it becomes aware of how you've done your Oracle licensing. If you have a VMware environment, whether it's on-prem or in the cloud, the system will discover that environment. We'll help you put in the licenses that you've purchased from Oracle and how those are configured properly so that you stay in compliance. And then the system will be sitting there giving you real-time alerting. So if anybody were to vMotion a workload onto an unlicensed host or install an Oracle product where they're not supposed to, the system will alert it in real time. And the benefit there is that if you get that alert right away and you can take action about it, remediate it, document those changes, within hours or days, the outcome in an audit is very different than what happens if it goes undetected for months or years. I think most importantly, with either of those offerings is we provide audit defense. So if you do get audited from Oracle, all you have to do is pick up the phone and we take over from there. So we're creating the Oracle Server Worksheet, OSW. We can interface with the Oracle LMS representative to try and get that audit resolved successfully with no adverse findings for you as a customer. And then with Premier, that's where we've enhanced that with those legal services and the financial guarantee. So if we give you bad advice on how to do your licensing, we have an insurance policy that backs that up. And that is unique in the industry, but it allows us to provide customers full peace of mind. Not too many people buy Oracle database licenses just for the sake of it. You have day-to-day activities that you have to do. You're delivering to your internal business units, your end customers. So we're really trying to help customers, again, avoid any compliance issues and make the most out of those licenses because they do have a significant price tag in most cases. A couple success stories real quickly. We've been able to help a number of clients, but two in particular. One was a customer where we were able to help them save over $16 million in Oracle licenses. Very simply, they were running a very pricey business intelligence product from Oracle. They thought if they virtualized it onto VMware, they were going to have to buy $16 million in new licenses. It was a complete non-starter for them. We helped them understand their options in there, and we were actually able to utilize VMware technologies to restrict that workload to a much smaller footprint, get them a lot closer to their normal operations, and they didn't have to pay for any new Oracle licenses. And they are covered to this day by the License Fortress Guarantee, so they don't have to worry about audits on how they've done that. The second one is with the State Exchange that we helped re-architect their environment, which drove a significant reduction in their annual costs. They were paying about $1.7 million a year in costs. And what we did was worked with them to understand their business requirements. We utilized VMware to help them reduce their physical footprint and consolidate workloads. And by doing that, we were able to basically refactor that underlying footprint and reduce their support costs. So their requirements really changed dramatically, and they were able to drop that support cost from $1.7 million a year to under $400,000 a year, saving them almost $4 million over 3 years. Finally, just to tie it all together, really trying to show customers how VMware virtualization can lead to significant savings. So we helped a customer recently that was running their Oracle databases Enterprise Edition on ODAs. They had ODAs in their primary data center as well as in their secondary data center, and they were doing everything between there mainly because of a little bit of confusion around how Oracle licensing worked. So we went in there and we talked to them about their options in there, but then we took it a step further to really talk to them on the optimization side. And what we realized was that 10 years ago when they had bought these Enterprise Edition licenses, there were real needs. They needed some of the features in there, like partitioning in particular. Now, 10 years had gone by, the hardware had increased quite significantly since then. And so we were able to get them onto a VMware platform. We did a POC with them, but we put them on a VMware platform sitting on Dell servers and EMC storage, and they were actually able to run their workloads on Standard Edition instead of Enterprise Edition. Well, this change was obviously very significant in a number of ways, but once we were able to migrate their production workloads onto Standard Edition on VMware, it allowed us to decommission their database appliances. We allowed them to decommission their secondary data center and start utilizing the VMware Hybrid Cloud in there, and ultimately it led to a 90% reduction in Oracle costs, and that 90% reduction helped offset the costs of having the VMware migration in there as well as the new hardware. So some real significant savings in there, but that's how these things all play together and can help customers really streamline their workloads and make the best utilization around those licenses as well as the technical capabilities that keep on advancing in there.